Gas producers strive to ensure maximum supply efficiency. The cost of the gas is directly dependent on several important parameters. A key cost indicator is the humidity of the gas during transportation. This parameter must be constantly monitored because moisture condensation in the gas pipeline leads to the formation of hydrate plugs. This can cause obstructions in the gas flow, increasing the risk of accidents. In addition, it has become increasingly necessary to install modern gas analyzers that have the ability to measure the hydrocarbon condensation temperature with a high degree of accuracy. Today, the most accurate method for measuring these parameters is the condensation method. This uses an optical system to register condensate formation on a chilled surface. This method is a first principle measurement. It is straightforward, reliable, and resistant to harsh conditions. The traditional version of this method for measuring the water dew point is simple. The measurement cell of an optical system incorporates a metal mirror, the temperature of which can be regulated. A sensitive temperature sensor is integrated into the mirror. Heating and cooling of the mirror is achieved by means of a thermoelectric battery. A light-emitting diode, or LED, is used as a light source, and a photodiode is positioned to receive light from the LED as it is reflected from the mirror. When the mirror is clean, virtually all the light from the LED is reflected by the surface of the mirror onto the photodiode. This results in the photodiode producing a maximum level of photoelectric current. But as the mirror is cooled, any water vapor begins to condense, forming droplets on the mirror's surface. These droplets act as tiny lenses that scatter the light from the LED. As a result, less of this light reaches the photodiode, and the photoelectric current it produces goes down. The mirror temperature at which the photoelectric current begins to decrease is registered as the condensation temperature. Subsequently, when the mirror is heated, the reverse process takes place and the droplets of condensation evaporate. As this happens, the light from the LED is no longer scattered, and the amount of light that reaches the photodiode goes up again, resulting in an increase in the photoelectric current it produces. The temperature at which this increase begins to occur is registered as the evaporation temperature. The average of the condensation temperature and the evaporation temperature is reported as the water dew point. But this type of setup doesn't work for hydrocarbons. During condensation, hydrocarbons do not form droplets, but a thin reflective film that does not scatter the light from the LED. Because of this, the amount of light reaching the photodiode does not decrease, so the beginning of condensation cannot be identified. A revolutionary method for measuring the hydrocarbon condensation temperature has been developed by the Vympel company. This method uses laser-based interferometric analysis and is based on the phenomenon of total refraction. Vympel's design features a vertically polarized laser as a light source and a chilled mirror made of a dielectric material. The vertically polarized light from the laser strikes this mirror at a specific angle, known as the Brewster angle. This results in total refraction of the laser beam. When the mirror is clean, the laser beam encountering it at the Brewster angle is totally refracted. As a result, no light is reflected onto the photodetector, and it registers a zero signal. But when a hydrocarbon film condenses on the mirror, total refraction does not occur. The light waves of the laser beam are partially reflected at the gas-film interface. At the same time, due to the optical transparency of the hydrocarbon film, a second beam of light appears following a slightly altered path. These waves are partially reflected at the film mirror interface. As a result, the photodetector receives two distinct reflected beams of light, which are out of phase, and these beams generate a pattern of interference. The registration of water condensation is slightly different. As the mirror cools, when water droplets begin to form, the light from the laser is scattered. This dispersed light is received by multiple photodetectors, which are positioned at different points around the mirror. The more droplets there are, the more scattered light falls on these photodetectors. The system registers light reaching these photodetectors as water condensation. The mirror in a Vympel device is a polished silica disc with a diameter of only 4 millimeters. The components of the optical circuit are assembled into a compact measurement cell. For instruments equipped with visual registration, hydrocarbon condensation is observed under vertical lighting. When a hydrocarbon film begins to form, iridescent patterns appear on the mirror. The hydrocarbon condensation temperature is measured when the film thickness is approximately 5 to 10 nanometers. For observing water condensation with the visual registration system, side lighting is used. Under side lighting, water condensation appears as a spray of tiny red dots uniformly distributed across the center of the mirror. Under vertical lighting, water condensation is also visible, appearing as tiny dark spots on a light background. Vympel 2-point hygrometers come in a range of models, each one having its own unique characteristics. All of these instruments provide a high level of accuracy and measurement quality for any technological area and under the most challenging conditions. The Hygrovision-BL dew-point hygrometer incorporates all of Vympel's most advanced developments in one device. The unique registration system in the Hygrovision-BL integrates the optical system found in previous generations of Vympel devices and a visual registration system that features a 40-power microscope for high-resolution observation of the mirror's surface. An onboard battery provides for up to 8 hours of continuous operation. The Hygrovision-BL can also be connected to an external power supply. Should this supply be interrupted, the analyzer will automatically switch to battery power. This makes the Hygrovision-BL essential equipment for those sections of the oil and gas infrastructure where continuous measurement of gas humidity is required. In order to have a clear view of the condensation mirror, the microscope is mounted directly onto the high-pressure chamber. Measurement processes, including changes in mirror temperature, are controlled by an electronic unit. This unit is operated by means of buttons and a touchpad. The Hygrovision-BL has been selected as a standard of comparison for International Gas Humidity Reference Standards for COUMET, or Cooperation for Metrology member countries. The Hygrovision-mini portable hygrometer was developed for taking spot checks in the field and as a reference analyzer for checking the results reported by online automatic hygrometers. The Hygrovision-mini incorporates the condensation method of dew-point measurement. Equipped with a 40-power microscope, the Hygrovision-mini provides for both vertical and side lighting, making it easy to clearly distinguish between water and hydrocarbon condensates. The lightweight portable instrument is conveniently operated by means of a keypad and display. Heating and cooling of the mirror is accomplished by a thermoelectric battery, eliminating the need for cumbersome refrigerants. Moreover, thanks to semi-automated features, the rate of cooling and heating of the mirror can be preset, allowing the operator to use the Hygrovision-mini to make measurements in accordance with GOST or ISO standards. The advantages of including vertical lighting in the visual registration system become apparent when comparison is made to the simple dew-point testers offered by competing manufacturers. For example, when the mirror is supercooled by 1 to 2 degrees Celsius in relation to a given dew point. In 2015, the Hygrovision-mini was awarded the prestigious Red Dot Award in the category of industrial design. For measurements in more extreme conditions, the Hygrovision-mini SL was developed. Based on the standard Hygrovision-mini, the SL model is suitable for taking manual dew point measurements under high pressure conditions. A special feature of the Hygrovision-mini SL is the incorporation of an enhanced side lighting system. With this model, it is possible to take measurements of the hydrocarbon condensation temperature and the water dew point at high pressures that are just as accurate as those made at atmospheric pressure. The Kong Prima 2M hygrometer stands out from all competing dew point analyzers. The Kong Prima 2M is equipped with self-diagnostic functions for monitoring the state of the sensor and analysis of the electronics. The surface temperature of the condensation mirror can be depressed by more than 70 degrees Celsius at operating pressures up to 160 bar, performance that surpasses its nearest rivals. The Kong Prima 2M is easily integrated into any telecommunication system via digital output using a Modbus protocol or via 420 mA analog communication. The Kong Prima 2M dew-point analyzer is compact, lightweight, and has 3 measurement modes: water dew point mode, hydrocarbon condensation temperature mode, and alternating mode for measuring both the water dew point and the hydrocarbon condensation temperature alternately. The operating menu can be accessed and controlled by means of 4 magnetically activated buttons using a magnetic key. In order to remove mechanical and aerosol impurities from sample gas, and to efficiently supply a representative gas sample to an installed analyzer at either operating or reduced pressure, Vympel has developed the SGA-003 gas preparation system. Installation and connection points are designed to accommodate Prima, FAS, and Hygrovision series analyzers. The SGA-003 system features an inertia gravity filter, which consists of a horizontal tube and a vertical tube. Heavier mechanical impurities are filtered out when the gas changes direction from the horizontal tube to the outer vertical tube, changing both direction and speed. As the gas slowly fills the vertical tube, lighter contaminants and liquid aerosols in suspension precipitate out and are eliminated. Purification of the gas without passing it through a filter cartridge or membrane eliminates the risk of sample distortion. The Prima 2M is available in 3 configurations: flow-through for installation into systems that supply the analyzer with a purified gas sample, flow-submersible for installation directly on the pipeline without interrupting the gas flow. In addition, thanks to Vympel's latest innovations, its alternative can be designed to provide zero-emission sampling. And flow-submersible with filtration for installation directly on a pipeline transporting gas that has mechanical and aerosol impurities. Vympel analyzers have flame-proof enclosures, but the sample gas passes through lines located outside this enclosure. This type of explosion protection reduces the risk of accidents due to gas accumulation inside the enclosure. Vympel has developed a solution that provides for water dew point and hydrocarbon condensation temperature measurements, comprising a combined system with Prima 2M analyzer mounted directly onto the gas pipeline. Measurements are taken automatically in alternating mode. One mirror and one optical system for both measurements. In this way, the device performs the function of 2 analyzers, one of which reports measurements at the operating pressure in the pipeline, and the other at a pressure of 27 bar. The pressure requirement for measurement at 27 bar is achieved by means of a pressure reduction system. If the gas is not purified, the combined system can be equipped with a filtration unit based on an inertia gravity filter. A service unit recalculates the water dew point measured at 27 bar to the operating pressure of the pipeline. The service unit can be used with Vympel analyzers as a secondary unit to provide not only conversion and recalculation of measured values, but also additional data interfaces and a display. The Prima 10C is the world's first online analyzer for measuring potential hydrocarbon liquid content in natural gas. The Prima 10C registers not only the hydrocarbon condensation temperature, but also other parameters as well. Given additional information about the temperature, pressure, and gas density, the analyzer calculates the amount of liquid that can be obtained from 1 cubic meter of natural gas. The Prima 10C is easy to operate, has an ergonomic, user-friendly control unit, and features both analog and digital outputs. This analyzer can be connected to a process computer, a maintenance panel, and a monitoring and measurement control room. As a supplement to its range of unparalleled chilled mirror dew point hygrometers, Vympel has developed the HyPro sorption-type moisture sensor. The HyPro is designed to measure the water dew point at temperatures down to -100 degrees Celsius and at operating pressures up to 300 bar. This sensor is designed mainly for measuring the moisture content in inert and aggressive gases, including those containing hydrogen. HyPro sensors are also an ideal choice as a cost-effective solution for natural gas treatment processes. The FAS automatic analyzer provides a combination of advantages. This compact and economical chilled mirror solution provides superior measurement results for process applications. The FAS can report gas humidity in terms of dew point and volume fraction of moisture. This analyzer can measure dew point over a wide range with an increased sensitivity to water vapor condensation. This ability is achieved through a reduction in the surface area of the chilled mirror, making it possible to lower the temperature by up to 95 degrees Celsius. This is an unparalleled degree of cooling for an online condensation hygrometer. A high level of explosion protection allows the FAS to be used for explosive media, including those containing hydrogen. This analyzer includes a built-in alarm, which alerts the operator to malfunctions and possible process violations. The FAS is compact, easily moved, and lightweight. It can be outfitted with a gas preparation system and can be installed directly on the pipeline, mounted on a submersible gas sampling probe with or without filtration. In 2020, the FAS Analyzer won the prestigious Red Dot Award for product design. Vympel dew-point analyzers and solutions incorporate proprietary technologies and innovations that have been developed by Vympel engineers and are protected by international patents. These high-precision instruments are supplied to more than 60 countries around the world. Prima, Hygrovision, HyPro, and FAS, solutions that are unequaled and irreplaceable.